Hi friends, welcome to the NPTEL course Strategy and Technology, a practical primer. We are in week 8 with the theme of Technology and Competitive Strategy. In this lecture, the 39th in the series, we have the topic of generic technology strategies. We have considered earlier how technology pioneers built firms and shaped industries. This lecture considers other technological developers such as the innovator, differentiator, and follower framework. Technology pyramid is a pyramid of these three types of firms. This technology pyramid influences and is influenced by the business strategy of a firm. Every firm has a strategy flow that comprises two principal components: investments in design, manufacturing, marketing, and support services, and earnings in revenues and profits. Technology has to help in experimentation, reimagination, and productivity. And these are the characteristics of innovators, differentiators, and followers respectively. The sequence and balance between innovative and follower technologies is well established in certain industries such as pharmaceuticals and electronics, while it is somewhat blurred in other industries such as automobiles and FMCG. Differentiators are closer to innovators than to followers. Differentiators can get patents for their discoveries, for their inventions. They may be following the innovators, but they are also innovative in their own right. Technology has these three categories as I mentioned. Innovative or discovery technology. This is the fundamental research. It creates new markets with pioneering products and services. Second is the differentiated technology. It follows the path set by the innovator but creates similar products having differentiated features. Quite often, innovators and differentiators start their journey of discovery at the same time. The innovators tend to be arriving at the goalpost faster than the differentiators. Follower or copycat technologists are those who come up later with products highly similar to innovator and differentiator products, mostly after the patents have expired. Here we are not talking about people who reverse engineer during the patent regime. We are talking about followers who do the technological development in a legally compliant manner. The extent and pace of differentiated products depends on the creation of additional intellectual property by differentiators. That's where innovative streak gets important for differentiators. For the follower products, it depends on the expiry of the intellectual property protection and the end of the attendant monopoly rights, which the innovators and differentiators enjoy. The sequence and the balance between the three classes of firms, that is innovators, differentiators, and followers, is very much important in the broader development of society and the economy, whether it is in India or elsewhere in the world. This is a graphic presentation of the technology pyramid. Innovators are characterized by pioneering spirit, a commitment to fundamental R&D. Differentiators have smart superiority. They follow the path but do it at times better than the innovators. Followers enjoy generally cost leadership. They seek and enjoy cost leadership. There is no research body that points to clear statistics of the ratio of innovators to differentiators to followers in any industry. In technology-oriented industries, it tends to be 1:5:20. And in commodity-oriented industries, it could be 1:10:50. The higher the complexity of the innovation of the top 10%, the greater will be the number of technology components. This provides an opportunity for differentiators, that is those who occupy the 30% space, to improve upon the components, making their product similar but with some specific smart and superior features. Most players occupying the major space find even partial improvements daunting, and they are satisfied with being just generic clones or copycats of the innovators or differentiators. But they provide the added benefit of cost leadership so that the society in the overall benefits. There could also be creative imitators, as we have seen in the three horizons of innovation: replicative innovation, creative innovation, and some kind of incremental innovation. Development of innovative technologies is challenging for a firm for two reasons which are integrated with each other. Fundamentally, innovation is technology and investment intensive. These are the blue circles. Only financially well versed and well endowed firms can perform in the innovation space. Well versed for intellectual property capability and well endowed for investment capability. Fundamental research certainly requires sophisticated equipment and high caliber people, and both of these cost a lot. On the other hand, some of the brightest technological innovations, be it genomics, epigenetics, stem cells, artificial intelligence, drones, etc., have been initiated on a small scale, on shoestring budgets, in startup or academic research formats. The fact of the matter is that it is difficult to categorize technology in a binary format, saying that this requires high investment and this requires low investment. Technology is therefore complex. It needs to be appreciated from multiple angles by firms as well as people. The relationship between technology and science has been age-old. Science is the foundation of technology. Technology is the application and further development of science in practical realms. There are four types of industries driven largely by different types of sciences as below. Material physical sciences, biological chemical sciences, electromechanical sciences, and digital computer sciences. The material physical sciences drive developments in technologies, products, and businesses such as steel, semiconductors, renewables, and oil. Biological chemical sciences drive developments in products such as Ayurvedic products, vaccines, a whole spectrum of pharmaceuticals, regenerative medicines, and so on. Electromechanical sciences drive developments in robotics, automobiles, machine tools, white goods, to quote a few. And digital computer sciences is the new thing. Artificial intelligence, Internet of Things, cloud, blockchain, and several others related to these domains are driven by digital computer sciences. In today's world, though, there is significant cross-dependence and convergence. Wearables, for example, are driven by advances in computer sciences and biological sciences as well. A lab on a chip is driven by both digital and scientific capability. I mentioned about strategy flow earlier. This is the graphic representing the strategy flow. A technology-driven product strategy is the core of business strategy. Therefore, the technology pyramid influences the nature of the business strategy of the firm. And it has two principal components, investments and earnings. Investments have to be made in design, manufacturing, marketing, and support services, whereas earnings for the firm come out of revenues and margins. Only those products which are on phase out can afford to be low on investments on all the four dimensions. The greater the technology intensity in each of these, the greater would be the competitive advantage. Revenue is made possible by sale of product, which is driven by technology and investments. That's where strategy execution matrix come in. Margin or gross margin is defined by earnings before depreciation, interest, and taxes. Usually it is the revenue minus the cost of producing a good or producing a service. The relative novelty of a product influences revenue and profit differentials between products and hence between firms. So when you look at two dimensions, one is the dimension of innovator, differentiator, and follower, and another is the dimension of investment and earning. Innovators need to be extraordinarily high on technical investments. These include design and manufacturing investments. Differentiators need to be extraordinarily balanced in terms of technical and marketing investments. They cannot afford to let one dominate the other. Followers need to be high on marketing investments but low on design and manufacturing investments. From the process efficiency point of view, innovators have space to develop gold-plated processes for their products if required, in the interests of having patentability. Differentiators need to be smarter than the innovators in terms of the process and product efficacy and efficiency. Followers need to be very agile, very focused in terms of minimizing the investments and maximizing the productivity. Innovators enjoy high earnings both on revenue and margin dimensions. Differentiators tend to be high on revenue grid and medium on margin grid. Followers tend to be low on both revenue and margin grids. Followers tend to be profitable in the overall based on the volumes. They are scale dependent. There are logically strong incentives for innovators, followed by differentiators and trailed by followers. The reality, however, is otherwise. Logic doesn't work always in this direction. Most firms tend to prefer a differentiator strategy or a follower strategy, and only the strong-hearted and well-endowed tend to pursue the innovator strategy. It is also a question of a company's culture, a company's vision. Big Pharma always looks at being innovator at any point of time, whereas generic pharma always try to be followers or creative followers. The flow of strategy is dependent on the interrelationship between strategy, investments, and earnings. Each firm needs to choose a balance of these three that is appropriate to its vision and strategy. In respect of technology, technologically superior business strategy that covers the whole of value chain demands higher investments, which is self-explanatory. But these can be addressed only by dexterous management of revenues and margins. Cash flow must be high. The ability to raise funds must be high to be able to be technologically intensive. Technology and investment intensity together make for a more exclusive industry setting that establishes high entry barriers. They also come with high mobility barriers and exit barriers too. So technology is like a boundary wall for the industry, but it also prevents companies from exiting that boundary all too easily. Investment intensity adversely affects the net margin potential of a firm because of depreciation and interest. Therefore, the business strategy has to decide whether you would focus all the resources on technology development or also on manufacturing efficiency or manufacturing throughput. You want to be asset light in certain other areas to compensate for the asset heaviness in the R&D area. There is a choice to be made in terms of business strategy. That's where again the previously thought about concepts of co-development, co-integration and co-fulfillment, as well as co-saturation and co-expansion come into play. Investments and earnings are proportional to the scale enjoyed in the marketplace, the price the product superiority or the customer experience brings to the company, and also the earnings level. No longer companies focus only on differentiation. Everybody tries to be of something else. Even innovator firms would like to be differentiators in respect of certain product categories, and if there is not too much of a conflict, they also would like to have followers. That's how many big pharma companies also started having generic divisions. This is a process that keeps on going in a roller coaster manner. Pfizer had a very strong generics division as part of its overall portfolio, but then it has clubbed its generics division with Mylan and made it into Viatris. So this kind of mix and match of the strategy blocks based on technology, based on the business potential keeps happening all the time. There is no one prescription that will stay strong for a multi-decade horizon. The characteristic strategies that are adopted by firms in the innovation are 6. First, they are in the forefront of experimentation. They keep experimenting. Even as companies have found a vaccine for COVID-19, the companies which are in the innovation basket will keep on working on vaccines for different kinds of viruses, and also whether there could be combination viruses which need to be tackled together. That is, if you have a vaccine for flu as well as vaccine for COVID rolled into one, and also capable of handling multiple variants, then that would be a winner. And that is the research that must be going on at this critical time. They also invest enormous resources, including time and effort, in their primary scientific drivers. That is, they know what they are going to specialize in. If there is a company which is focusing on mRNA technology, all the resources would be put in that area. Similarly, if the strategy is one of biologic development in terms of oral pills, in terms of antibodies. Resources would be put in that area. So we have to understand for yourself the key technological goal you would like to have and put your resources there. And those technological goals could be more than one. And invest resources in exploration of how the other drivers can also be leveraged for greater innovation. That is, one is discovery, the second is delivery. It is not merely the basic drug molecule or the vaccine that is going to be useful, but also the device combination, also a combination with other medicines that could be very effective. So there would be investment of resources even for innovator companies in related areas. Together, it could be a combination of innovation and differentiation achieved simultaneously by those innovators. And innovative firms are certainly driven by insightful and intuitive leaders who are visionary, who are committed to innovation, and they are not generally data-oriented analytical leaders. Although every CEO is expected to be accountable to numbers, particularly the revenue, profit, and various other performance numbers, the primary motivation, inspiration comes from their visionary approach to developing business onto new trajectories. And they are risk-oriented. They don't mind failures. They are not disheartened by failures. They take every failure as a lesson to do something different. In big pharma, many drugs fail, but that doesn't deter such leaders from attempting more of such drug development projects. They press on with resource allocations until pioneering breakthroughs are achieved. And when the pioneering breakthroughs occur, one of such pioneering breakthrough can take care of 10 failures that may have happened en route to this achievement. Microsoft acquiring DNA sequence to store trillions of data bytes is an example for innovation leadership. Another example is driverless cars combining automobile, navigation, sensor, imaging, and computer technologies. Ability to combine different industries into one industrial crucible. The characteristic features of differentiation are quite different. Fitbit wanting to launch a fitness watch is an example of differentiation. Despite the launch of Apple Watch or Samsung Gear smartwatch, Fitbit fitness band continued to be popular. It is that brand value, brand equity that Fitbit would like to leverage. But the firm also recognized that getting a watch bezel onto the band with additional functionalities would be a key differentiator and portfolio enhancer. So the characteristics of differentiating firms are four. They tend to take off on this path when innovation is temporarily halted or potentially competed. Second, they are driven by observant and thoughtful leaders who are primarily creative rather than analytical. They integrate multiple components of a successful innovator system, and they reimagine a new value proposition that brings smart superiority to relevant parts. When companies believe that they have an innovative pathway on their hand, but it is probably not appropriate to look for the final pioneering product, they might kind of branch off into the differentiation mode and try to get it in a superior fashion, even if the innovator is ahead of them. And they also have certain leadership characteristics. They are very observant and thoughtful in terms of leadership, and they are creative. They are not analytical. They share that not being analytical characteristic with the innovation leaders, but the visionary approach is replaced by the observant and thoughtfulness approach. And they are reimaginers. They visualize. If pioneers imagine a future, these leaders, these companies reimagine a future. Modular products that we have had in the recent past, such as Ashok Leyland AVTR trucks, which enable modular enhancements and optimization for customized operation of trucks, is an example of smart differentiation. What are the characteristic strategies of followership? Followers are productivity driven. They have got all the technology tailor-made by them through the work of innovators and differentiators. And the regulations also require a low level of entry. They don't have to prove that their product is superior from all angles. They just need to clone the results, final results of the innovators and differentiators, and they would get their approvals. The generic pharmaceutical industry is a particular example of how follower productivity enables me-too followers transform the structure of an existing industry. And in this process, it virtually built a whole new industry segment successfully. There are 4 characteristics of follower firms. They need agility, they need precision and accuracy and efficiency to play the commodity game successfully. They got to standardize on SKU units and they got to play on the margins. Even if it is a 5-cent margin, they should compensate by having huge volumes for that 5-cent product. They keep their commoditizing follower template ready even as the innovator products are launched. They keep planning months and years ahead for the day when the patent protection is off and they can enter the market. Therefore, they are adaptive, they have their own type of foresight, and they are quick on the go. They tend to be operational and efficiency experts. The leaders particularly are very much focused on task leadership, operational excellence, and agile manufacturing. Generic followers succeed based on the quality of management and rigor of operations, and their metrics are completely different from the metrics that differentiators and innovators have. Followers understand that the marketing universe is so diverse and the bottom of the economic pyramid is so large that there would always be scope for follower products in adequate numbers if they are affordable. And if you are able to have creative differentiation or creative improvement in the follower product, it is icing on the cake. These are the characteristic strategies of followership. While speaking of technology and innovation, I would like to draw upon the example of crystallization. Those familiar with solid liquid physics and chemical engineering understand that crystallization is a complex process. There are many natural crystallization processes that are time dependent. Examples: mineral crystals or slow flakes. Laboratory crystallization works on several parameters such as concentration, temperature, polarity, ionic strength, etc. to ensure the required crystallization. Crystal growth happens when the primary crystallization or the first nucleus formation, that is convergence, takes place. Then secondary crystallization follows. Innovation likewise is time dependent. Leaders committed to innovation need patience. Innovation similarly requires specialization, energy, passion, and persistence. Innovation also starts with one unique idea and then builds on to make a whole new innovative product eventually. Examples are electric cars built around high-performance electric batteries, smartphones around bright displays, sharp camera modules and smart sensors, renewables based on efficient but low-cost solar modules, and so on. Innovation requires patience along with focus. We will then look at commoditization. Because technology not only supports innovation but also, ironically, supports commoditization. Even highly sophisticated technologies with high investment intensity are subject to rapid commoditization if they are not protected by patent and monopoly rights. Commoditization has 5 facets. It stimulates proliferation of competing products with same or highly similar features. Commoditization occurs when a core or base product is recast into multiple end-user products, as in the case of iron and steel. Commoditization also tends to occur as more systems developers and component makers get their teeth into their own proprietary technologies. Commoditization is an inevitable outcome of outsourcing of design, development, and manufacture. It supports a wide base for followers and works to the advantage of consumers. This phenomenon of commoditization was widely commonplace in white goods, home appliance, and FMCG industries because the patent barriers there are by and large lower. However, this is now evident in electronics and other industries as well. So, having looked at all of these concepts, let's look at one company which has been known for its innovation. This is a case study of Corning. Corning is a technology company specializing in glass and ceramic materials. It was founded in 1851. Amory Houghton was the founder. Headquarters is in Corning, New York, USA. It has a revenue of $11.3 billion and a net income of $512 million. It is a publicly listed company with 51,500 employees and plants in USA, China, France, Mexico, and Poland. The products include ceramics, specialty glass, optical fiber, cable, hardware and equipment, emission control technology, LCD glass, life science products, and so on. It had a framework that was built on its core leadership philosophy: operating the business exceptionally well, investing for profitable growth opportunities that align with focused portfolio, de-risking investments through customer commitments, and distributing cash to shareholders. This strategy and growth framework has been setting leadership priorities in the past as well as for the future. The goals for 2020 through 2023 are sales CAGR of 6 to 8%, EPS CAGR of 12 to 15%, and investment of $10 to $12 billion. Increase operating margin, deliver $8 or 10% to shareholders are the returns goals. Since the company started, innovation drove the company. The founders of Corning Inc. instilled a belief in unique product creation, including life-altering innovations such as the light bulb, TV tube, and optical wave guides. Innovation is Corning's essential program, bridging functional groups within the organization, renewing itself through continued time and iteration. Innovation not only challenges established and traditional ways to thinking, but has become key impetus to drive change. It converts ideas into opportunities for Corning. That's how it has been innovatively effective. Corning realized long ago that it needed to develop links between technology, marketing, and manufacturing. They have developed a process by which Corning creates, identifies, evaluates, prioritizes, and executes against market opportunities. And there have been lots of common cross-functional approaches, a common language and understanding between teams of people, a framework to hold together the team in a global sense, participation by all functions in the execution of the project from the beginning, assistance in outlining deliverables, shared ownership of the project, and an ability to balance between market requirements, manufacturing, and technological capabilities. Some of these concepts we have discussed as part of our various lectures. It had a disciplined approach to managing innovation. Radical innovation, yes, but highly managed innovation. There have been 5 steps in making this happen, which is explained as I come to the next slide. Second is the vision and core technology competence. Corning invented the optical fiber because of its deep knowledge of materials technology and high-speed manufacturing, and its systems perspective of how various pieces of optical communication network fit together. It has the ability to develop and manage project portfolio and also involve cross-functional teams in the process. The whole Corning innovation process is driven by project leadership. The importance of practice is very much recognized as part of the radical innovation framework. The company selects project leaders based on their innovative leadership skills and cross-functional understanding of technology. And there is a 3-year horizon that is set always to make sure that the projects don't go astray, nor that they don't go to eternity. The 5 steps of Corning to turn an idea into a successful new project or a new product are as follows. 1. Building knowledge and road mapping. That is the fundamental first step. 2nd, determining feasibility. Testing practicality, providing profitability, and commercializing and improving continuously. So between feasibility and practicality, much happens in terms of the development of the product. But knowledge building and road mapping is also vital. That sets the tone for project management of the product. Corning versus Cisco. Both are technology companies in different senses. But Corning has been superior to Cisco, although Cisco has been a technology company, because Corning acquired talent that develops innovative products, the ultimate source of competitive advantage of technology companies. As a rule, most of the innovative products of Corning are developed internally by leveraging and combining its own capabilities. And its strategy of relying on internal talent for innovation has helped cut innovation costs while creating higher and more sustainable competitive barriers at the same time. Corning's operating model had 3 pillars. 1. Technology management, 2. Process management, and 3. Talent management. Sizable amount of money is reinvested in R&D. So intellectual property is considered as one of the most valued assets for it to grow. Second, Growth and Strategy Council comprises of its CEO and technology officers, and it is the mission to maintain a balanced and robust innovation portfolio through pacing investments in individual programs and making resource allocations between the company's existing and developing businesses is the motto. You can see that it provides a way in which a company as complex as Corning could allocate resources across various projects while maintaining a balanced and robust innovation portfolio. Talent management is the third pillar. Corning recognizes that investment in talents are the utmost necessity, and the only way the firm will be able to ensure that operational gain translates into revenue. Some of the innovations of Corning are well known, but the innovations that are going to come in future are exciting. Corning glass for interior architecture for the high-end look, which cannot be achieved with other surfaces. Advanced flow reactor products. These are designed to scale up and do process development for multi-ton industrial production of chemicals. Corning Guardiant is an antimicrobial additive that can be dosed into paints and coatings, and these coatings continuously kill 99.9% germs on walls, including COVID-19 virus. Corning Varioptic lens. These lenses rely on the electrowetting principle, where the interface of two liquids is modified when a voltage is applied. This meets a number of industrial applications, particularly related to lenses. Corning Willow Glass. It uses the proprietary fusion drop process of Corning, and it is manufactured at thicknesses that create unique properties such as the ability to be flexed, and these are going to be the fundamental drivers of foldable phones and foldable smart devices. Fibrance Light Diffusing Fiber. This is an innovative optical fiber created from a unique glass for maximum flexibility, allowing it to warp, curve, wrap, or bend it at around almost anything. If you see these innovations, you will see that the material technologies are at the core of Corning's innovations. It is the core competence. Science and technology drive these kinds of products, which are generally first into the industry and first into the market. The innovation timeline itself is very exciting. In 1851, it started as a small glass company. Then it improved railroad safety by designing a revolutionary lens for signal lanterns, a product which is so simple and so much cognizant of railway requirements. Then it made electric light a reality by developing a glass encasement for Thomas Edison's carbon filament. It developed Pyrex glass, creating a successful line of highly durable cookware and industry-leading laboratory products. Then in 1934, it created high-purity silica, the foundation of numerous innovations from telescope mirrors to 3D sensing components. In 1935, world's largest piece of glass to date for the groundbreaking Halley telescope. 1939, invents a process to mass produce TV picture tubes, helping to make televisions affordable for millions. In 1952, develops glass ceramics which withstand extreme temperature. 1970, first ever low glass optical fiber. 1982, thin, flat and stable LCD glasses, the core of new TV technology. Corning introduces OptiTap connectors, laying the foundation for Internet of Things, way back in 2004. Invention of damage-resistant Gorilla Glass, another game changer for smartphones. It also introduces Clear Curve, an industry-changing fiber that can bend at 90-degree angle. Then in 2015, supplies high-precision mirrors for NASA's New Horizons mission to capture the first ever detailed images of Pluto. And then Corning goes on to introduce Gorilla Glass for automotive and Gorilla Glass SR Plus for wearable technologies with exceptional scratch resistance. And Corning creates glass packages for pharmaceutics, Valor Glass. The invention of Gorilla Glass itself is a project that is demonstrative of its innovation. when cell phone makers challenged Corning to develop a cover glass that would be more durable than soda lime glass or plastic that was prevalent at that time, the company produced its most popular Gorilla Glass in just 3 months. That 3 months includes the time taken from the thought of making the glass to develop and manufacture it and finally introduce it into the supply chain. The Gorilla Glass was launched in 2007 and is still found on hundreds of millions of consumer electronic devices and is climbing towards multi-billion in annual sales with continuing innovations. No phone gets made without Gorilla Glass these days. Corning's stage gate innovation process has been structured to enable that kind of nimble response while ensuring concurrent engineering and quality assurance. Again, concepts which we covered in various aspects of our lectures. Right now, Corning Gorilla Glass Victus is supporting Samsung foldable phones. It is another innovative first. There have been 4 major waves of innovation under Corning's leaders. I mentioned in an earlier lecture that leadership and innovation are closely linked. I also said that innovative leaders or leaders of innovative companies are visionaries. They take risks and they look for a future far beyond what others can look for. Under the leadership of Dr. Eugene Sullivan, Corning developed new glass for railroad lanterns, new methods of producing light bulbs, and invented the composition of Pyrex, which led to Corning's foray into the laboratory glassware and consumer product businesses. That has been the foundation. Glass is the one which bound together Corning's innovation methodology. Then Jesse Littleton led Corning's R&D efforts during the 1930s. He was the dean of physical properties of glass. Silicones and cathode ray tubes for televisions are his key contributions. Then came William Armistead. He was the director of R&D at Corning during the 1950s and 1960s. He was responsible for more than 50 new glass compositions. Corning ware, photochromatic glass, and the first commercial tubes for color television are some of the key inventions from his era. Then Jock Hutchins, David Duke, and Charles Kip Deneka led Corning's 4th wave of innovation from the 1970s through the 1990s. They drove Corning's leadership in telecom while also making their personal marks on Corning's research efforts. The foundations, when they are strong, they will support the superstructure as more contemporary developments take place. The distinctive innovation recipe is fourfold. Address tough technology challenges. It didn't keep the horizon near. It always pushed the envelope in terms of developing new material technologies and achieving the impossible as it looked at that point of time of development. It combined material and process innovation in all its products and projects. It collaborated with customers who lead their fields and transformed industries to deliver long-term value. So if you analyze Corning, unmatched core competencies, in-depth specialization in material technologies, outstanding technical and business leadership from inception, and preferred strategic supply relations with all majors drove Corning's innovation drive. As a result, the financials have been stable and earnings also have been positive in the last few years. These are the notes related to Corning. You can go through when time permits. With this, we come to the end of this lecture. Thank you for your attention.